Ever think about all that data flying around us? It's crazy. Emails, video calls, streaming, all that stuff works because of something called data link control.
Yeah, it's like the behind-the-scenes hero, keeping those little data packets moving smoothly across the network, keeps things from crashing into each other and causing digital chaos.
So like a traffic system for the internet. But with billions of devices online, how does it not get completely jammed up?
That's where we get to network segmentation. Imagine a city, millions of people trying to get around. You need separate roads, tunnels, maybe even a subway, right? To keep things flowing.
So we're dividing the network itself, not just managing the traffic, but making it into smaller chunks.
Exactly. And VLANs, virtual LANs, that's a big tool for this. Carving up a physical network into separate logical networks.
Okay, so picture a cable connecting computers in an office. With VLANs, it's like those computers are on totally separate networks, even though they share a cable.
You got it. It's like invisible walls inside the network, separating teams or departments. Better performance, and it boosts security, too.
Wait, how does that make it more secure? Don't we have firewalls for the whole network?
Firewalls are good for overall protection, yeah. But VLANs give us more control. Like, imagine a security breach in one department. VLANs contain it to just that segment, so the intruder can't grab sensitive data from other departments.
Like a fire contained to one building, not spreading to the whole city. That's a good way to think about it. But how does the network know which data goes where with all these VLANs?
That's where 802.1q tagging comes in. It adds a tag to each data packet, shows which VLAN it belongs to. Like a digital barcode, it tells the network switches where to send it.
So not just separate lanes on the highway, but each vehicle has a label saying where it's going.
Precisely. Keeps data from ending up where it shouldn't, protects sensitive info from the wrong people.
Makes me think. All the types of data on a network, some are more important, right? How do we make sure, say, video calls don't get stuck behind less urgent stuff?
You're onto quality of service, or QoS. It's the priority system for data traffic, making sure the important stuff gets treated like it's important.
So VLANs organize things, but QoS makes the flow better depending on what the data is.
Exactly. Lots of QoS tools out there. Traffic shaping, for one, smooths out bursts of data, regulates how fast data is sent to prevent congestion.
So like traffic lights on the data highway, preventing everyone from hitting the gas at once.
Perfect analogy. Then there's policing, which enforces limits on how much bandwidth certain types of traffic can use. Say, a streaming service is hogging everything. Policing can step in, restrict it, make sure other apps get their fair share.
So shaping is smoothing things out. Policing is like setting speed limits. But what if we need some data to always get through, even at rush hour?
Then we've got differentiated services, or DISServ. This is like express lanes for high priority traffic. Mark packets with different priority levels. That way, critical stuff like voice calls or real-time data always have the bandwidth they need.
This is amazing. We went from splitting the network with VLANs to managing the flow with QoS. We're building a whole system here.
We are, and to make things even more efficient, we have Power over Ethernet, PoE.
Yeah, PoE. For security cameras, wireless access points, all that. But how does it fit into this whole network efficiency thing?
PoE sends data A and D power on the same Ethernet cable. No more separate power outlets for every device.
Super convenient.
Yeah.
Fewer cables, less clutter. How does that even work, though? Special cables.
Not always. Standard Ethernet cables can often do both. It's all about the IEEE 802.3 AFAT standards. They set different power levels and how it's delivered, making sure everything works together.
Like different electrical outlets, each with a different power capacity.
Exactly. Combine data and power, simplify installations, cut costs, and the network is even more efficient.
Wow, I'm seeing how complex networks really are. Went from data link control to this well-organized network with VLANs, QoS, PoE. We've practically built a whole digital city with traffic systems and power grids.
And like any city, our network needs constant tweaking and adapting as our digital world keeps growing.
What are some of the things that keep network engineers up at night?
The Internet of Things, for one. It's exploding. Billions of devices coming online, all that data, all needing bandwidth.
Like our digital city suddenly having a population boom. How do we handle that?
That's what we'll dig into next time. How network segmentation and efficiency are key to managing the crazy world of the Internet of Things. It's not just the number of devices, though. It's the types of data and how important it is.
Like, what do you mean?
Think about a smart factory, sensors all over, tracking temperature, pressure, vibration, everything. That data needs to get to the control systems instantly to keep things running.
Yeah, any delay there and...
Exactly. Disaster.
Yeah.
Then you've got security cameras, lots of bandwidth, but not as time sensitive.
So that sensor data, even if it's less overall, has to get priority.
That's where QoS comes in. Tag those packets as high priority, they get through fast, even when the network's busy.
QoS really is the backbone of this whole Internet of Things thing, isn't it?
Absolutely, and not just factories. Self-driving cars, they need constant sensor data to navigate.
Flag there and... Yeah.
Serious consequences. Those networks have to be rock solid, QoS, making sure the right data gets where it needs to when it needs to.
Okay, so QoS is huge as the Internet of Things grows. What other challenges are there?
Security, big one. Billions of connected devices. That's a lot of ways in for hackers.
More devices, more vulnerability.
Precisely. And a lot of these IoT devices, they're cheap, simple. Security isn't always the top priority.
So they're easy to hack.
Exactly. And once one's compromised, it can be used to attack others or the whole network.
That's kind of scary. What can we do about it?
Network segmentation, crucial here. Isolate different types of devices into their own VLANs, you limit the damage.
So if one gets hacked, the others are still safe?
Exactly.
Yeah.
Firewalls between different parts of our city. A small fire doesn't become a huge one.
Makes sense. Any other security stuff?
Strong authentication. Got to make sure only the right devices connect and that they're actually what they say they are.
And that they haven't been tampered with.
Right. And encryption. Got to protect that data moving between devices. Stop eavesdropping.
The Internet of Things is complicated. Not just connecting things, it's managing them, keeping them safe, efficient.
You got it. It's a whole ecosystem of technologies working together.
So what's next for networks? What are the big changes coming?
Software-defined networking, SDN, that's a big one.
I've heard of it, but explain it like I'm 5.
It's about making networks flexible, programmable. Instead of smarts locked in the hardware, we move them to software.
So we have one control panel for the whole network.
Exactly. And that panel lets us change and manage things in real time. Adapt on the fly.
That sounds powerful.
It is. SDN automates stuff we do manually now, saves time, fewer errors.
And it helps us handle those changing traffic patterns we talked about.
Right. SDN is going to be key for the Internet of Things, managing all that complexity and scale way better.
SDN's one big trend. What else is coming?
5G and beyond, that's a game changer too.
5G's everywhere now, but how's it linked to the Internet of Things?
5G is built for way more data, way less lag than older cell tech.
So it can handle the huge amounts of data from all these devices.
Exactly. And the low latency means near real-time communication.
Important for, like, self-driving cars or doing surgery remotely.
You got it. 5G is going to open up things for the Internet of Things we couldn't even imagine before.
This is so cool. It feels like we're at the start of something big.
We are. The Internet of Things could change everything, how we work, how we live, everything.
And it's all built on this foundation of network segmentation and efficiency, right?
Couldn't happen without it.
This has been quite a journey. Started with data link control and ended up talking about 5G and the future.
It's crazy how all these different technologies connect in the end.
Like a puzzle, forming this massive network.
And it's only going to get bigger and more complex.
Which makes understanding the basics even more important so we can see how it all fits together.
I agree completely.
I'm starting to see how big this shift really is. It's not just like faster internet or new gadgets. It's how the whole world works.
And that brings up a lot of questions. How do we make sure all this powerful tech is used the right way, ethically?
Yeah, we've been deep in the technical stuff. Can't forget about the human side.
Exactly. Like any big change, the Internet of Things, it has risks and benefits.
What kind of risks?
Privacy is a huge one. Sensors everywhere, collecting data on everything we do. Who controls that data? What happens to it?
It's like Big Brother, but worse.
Kinda, yeah. And there's the risk of discrimination, too. If algorithms are making decisions based on this data, they need to be fair.
So the technology itself is important, but so are the rules around how we use it.
Exactly. We need open discussions, frameworks that protect people's rights while still letting good stuff happen.
This makes me think about the bigger picture, like societal impact, the Internet of Things. It's not just a tech issue, it's a human one.
Definitely. We need policymakers, tech people, everyday people, all working together to get this right.
So it's not just about building the tech, it's about building a better future with the tech.
You said it perfectly. That's a challenge we all got to be a part of.
This deep dive has been amazing. We started with the basics, network segmentation and all that. But we ended up talking about, like, the biggest questions out there.
It is interesting how tech stuff can lead to such big ideas.
It shows how technology is never just about technology. It's about us.
Couldn't agree more.
So as we finish up, I feel two things: excitement for what's coming and the weight of making sure it's used for good.
I like that. Excitement, A&D, responsibility.
Thanks for coming on this journey with me. It's been great learning from you.
It's been a pleasure. Really enjoyed it.
And everyone listening, thanks for diving deep with us. Hope you enjoyed exploring network segmentation and efficiency, especially in the age of the Internet of Things.
Keep learning about this stuff. Be part of the conversations that'll shape our future.
All right, so let's dive into network security.
Okay.
Specifically, we're going to be focusing on the data link layer.
Right.
And we've got some really interesting research here about how data stays safe and travels efficiently.
It is a critical area.
At this level.
Especially with, how technology is evolving.
Yeah.
We're seeing exciting innovations in how we manage and secure data.
Absolutely.
As it moves across these networks.
So to give everybody a little roadmap of what we're going to be talking about today, we're going to be covering 802.1x authentication.
Right.
We've got MACsec encryption. We're going to be talking about newer protocols, software-defined networking, and shortest path bridging.
Very cool.
And then to kind of compare and contrast, we'll also be touching upon some older technologies like frame relay.
Right.
So get ready for some aha moments because these advancements are incredible.
Oh, yeah. I think you'll be surprised by how much things have changed.
Yeah, it's really remarkable.
Yeah.
Okay, so let's start with 802.1x authentication. I know this is really important for network access control.
It is.
But to be honest with you, it's kind of always sounded like a secret code to me.
Well, it's actually simpler than it sounds.
Okay.
Imagine a security guard checking IDs at the entrance of a building.
Yeah.
802.1x is kind of like that security guard for your network.
Right.
It's verifying the identity of devices before it grants them access.
Got it.
And this happens in both wired and wireless networks.
So it's making sure that only authorized devices...
Only the devices that are supposed to be there are allowed to connect.
So it's kind of like when you go to a high-security facility, they always check your ID very carefully.
Yes.
But I'm curious, what makes it so effective? Is it analyzing the device in some way, or is it just like a password check?
So it goes beyond a simple password.
Okay.
It uses something called a three-way handshake between the device, an authenticator, which could be like a network switch, and then an authentication server. So the server, it holds the credentials, and the authenticator, that acts as the middleman.
Right.
It's basically verifying the device's identity before allowing it on the network.
Wow, so it's a much more rigorous process than I initially thought.
Yes, definitely.
Now, I'm wondering about, the user experience.
Yeah.
Does it slow things down for the user?
Well, there is a brief authentication process, right?
No.
But the impact on speed, especially with modern hardware, is pretty negligible.
Okay.
And, the benefits really outweigh any kind of small delay that might be there.
Makes sense.
Because think about it. It prevents those unauthorized devices from connecting and potentially wreaking havoc.
Right.
And this is particularly important, for wireless networks.
Yeah, absolutely.
Where anyone within range could potentially try to connect.
That makes perfect sense.
Yeah.
Especially with everything is getting so much more connected these days.
Exactly.
More and more devices.
Yeah.
Yeah, a little bit of a delay is a small price to pay for good security.
Absolutely.
Okay, so let's move on to MACsec, which stands for Media Access Control Security.
Okay.
I've heard of MC addresses.
Right.
MACsec, now this is where it gets interesting.
Yeah, so MACsec, you can think about it as adding an extra layer of encryption to those data packets themselves.
Got it.
So if 802.1x is like that security guard at the door,
right.
MACsec is the high security armored vehicle transporting valuable cargo inside the building.
Gotcha.
It encrypts the data frames before they even leave the device.
So even if somebody manages to tap into the network,
right,
they can't make sense of the data.
Exactly.
Unless they have the decryption key.
That's right.
Wow, that's a powerful level of protection, especially in an age where data breaches are becoming more and more common.
Absolutely.
Yeah.
And, this encryption happens at the data link layer, which is lower down the networking model than where another encryption protocol called IPsec operates. So you've got security working at multiple levels.
Oh, so it's like multiple layers of defense.
Exactly.
I like that.
Like those medieval castles, you know?
Right, with multiple walls and moats.
You'd have to be a very determined attacker to get through all of that.
Yes, absolutely.
Yeah.
And these security measures have become even more critical.
They have.
With all these advancements in network management.
Right.
Take, for example, software-defined networking.
SDN.
SDN, that's right.
It's a hot topic.
It's a hot topic. It's changing the way networks are managed.
It is.
But to be honest, I'm still a little bit fuzzy on the details.
Okay, so think of traditional networks as a city with a complex system of roads.
Okay.
Each with its own traffic lights, its own rules.
Right.
SDN is like having this central control center
Gotcha.
that can monitor and manage all of those roads and signals
In one place?
from a single point.
Wow.
It just brings this level of flexibility and control that wasn't possible before.
So instead of each device managing its own connections, there's like this central brain that's orchestrating everything.
That's a great way to put it.
But doesn't that also mean that if that central point is compromised, that there's a huge risk?
Yeah, you've hit upon a very key consideration.
Right.
The benefits are huge. You can dynamically adjust your configurations, you can prioritize traffic, you can create these virtual networks all within the same physical infrastructure.
Yeah.
But securing that central controller, that becomes absolutely paramount.
Yeah, it's like the crown jewels. If that falls,
Exactly.
the whole kingdom is at risk.
Right.
And I'm imagining that the security measures we were just talking about,
Yes.
like 802.1x
Right.
and MACsec,
Absolutely.
are going to play a vital role in protecting SDN.
They become even more critical in SDN because that controller becomes a high-value target for attackers.
Right, because that's the one point
Exactly.
that you can compromise the whole system.
Right, so securing that control plane is essential for the integrity of the entire network.
It's like having a highly trained security force guarding a city's control center.
Exactly.
You really need the best of the best to protect that critical asset.
Absolutely.
Okay, so before we move on, I want to ask about something else.
Sure.
So we've been talking about like how data is protected as it's traveling.
Right.
But what about making sure that it's taking the most efficient route?
Right.
This is where something like shortest path bridging comes in, right?
You're exactly right. Shortest path bridging, SPB for short, it really revolutionizes how data finds its way through the network.
Okay.
So imagine you're navigating a city with multiple routes to your destination.
Okay.
SPB is like your GPS,
Got it.
constantly calculating and choosing the shortest, most efficient path.
So it's not just about security anymore.
Right.
It's about performance.
Exactly.
This sounds like a big step forward from the older routing protocols.
It is a major leap forward. Older protocols like, spanning tree protocol,
Right.
while they were good at preventing loops, in the network, they often resulted in less efficient paths.
Got it.
SPB, it utilizes all available paths, ensuring that data reaches its destination quickly and efficiently.
It's like a super efficient traffic management system.
Right. No more unnecessary detours.
No traffic jams.
Exactly.
And I imagine this becomes even more crucial in today's world,
It does.
where speed and efficiency is so important for everything.
Yes.
Whether it's streaming video or you're doing transactions online,
financial transactions, all of that.
everything.
Speed is key.
And so this is a great example of how these advancements at the data link layer have a real impact on user experience.
Absolutely. I mean, you might not see it, but it's happening behind the scenes, making everything smoother and faster.
It's like the invisible hand that keeps the digital world running smoothly.
Exactly.
Yeah, we take it for granted, but without these advancements, I mean, the internet would be a very different place.
It would be. We'd be going back decades
Yeah.
in terms of speed and efficiency.
Right, and just to kind of put things in perspective, let's look at frame relay, which was, a big deal back in the day.
Right. The old days.
But I imagine that compared to the protocols that we're talking about now, it looks pretty old-fashioned.
So frame relay, it did serve its purpose,
Of course.
especially for connecting businesses across wide area networks,
Uh-huh.
but it had its limitations.
So let's unpack those limitations.
Okay.
What were some of the shortcomings of frame relay compared to like SDN
Sure.
and SPB?
Right.
Was it primarily a matter of speed?
Well, speed was definitely a factor, right? I mean, frame relay was designed for a different era
Right.
with much lower bandwidth requirements.
Right.
But even more important than that, it lacked the inherent security features and that flexibility
Well,
that
yeah.
you see in modern protocols.
Got it.
So security was often addressed with add-on solutions, which weren't always as robust or efficient.
So it's like comparing a horse and buggy to a high-speed train.
It's a great analogy. Both can get you from point A to point B.
Right.
But the experience and the capabilities are vastly different.
It's a whole different world.
Absolutely.
And this really highlights why frame relay has been, for the most part, phased out in favor of newer, more efficient, and secure technologies.
Exactly. It simply couldn't keep up with the demands of the modern digital world.
And this is a great example of how fast innovation is happening in the world of networking.
Absolutely.
What was once considered cutting edge very quickly becomes obsolete.
It does.
As new challenges emerge and new solutions are developed.
That's right.
And I'm eager to learn more about those challenges and solutions.
Well, we've laid the groundwork here with these fundamental protocols and concepts.
Right.
Now let's delve deeper into the evolving landscape of data link control and explore some of the more recent advancements that are shaping the future of network security and efficiency.
Okay, I'm ready to dive in.
Let's go.
Let's do it.
Right.
Let's see what fascinating discoveries await us.
Okay. As networks get more complex, right?
Yeah.
And the volume of data just keeps, exploding.
Right.
The need for even more sophisticated solutions at this data link layer has become really apparent. One area where we're seeing a ton of innovation is in this realm of quality of service.
Okay.
QoS.
Okay, yeah.
It has to do with prioritizing certain types of network traffic.
Right. So making sure that if you're on a video call,
exactly,
that somebody downloading a huge file isn't going to interrupt your call.
You got it. QoS is all about ensuring a smooth and consistent user experience by managing those network resources really effectively.
Got it.
In the past, QoS was handled at higher layers in the network.
Okay.
But now with these advancements in data link control, we can implement QoS mechanisms at a much more granular level.
Okay.
Closer to the source of the data.
That makes sense. The closer you are to the source, the more control you have over how that data is treated. So how does QoS work at the data link layer? What are some of the techniques that are being used?
So one technique is called traffic shaping.
Okay.
And that involves controlling the rate at which data is transmitted.
Right.
Think of it like a traffic officer regulating the flow of vehicles on a highway.
Okay.
So by prioritizing certain types of traffic, you can ensure that, those critical applications like video conferencing or real-time monitoring systems receive the bandwidth that they need, even when there's a lot of network congestion.
So it's like having a fast lane for important data.
Exactly.
While, less time-sensitive traffic might have to wait a little bit longer.
That's a great way to think about it.
But what's to stop, somebody from just prioritizing all of their traffic over everybody else's?
Yeah, so that's where careful configuration and network policies come into play.
Right.
QoS is a powerful tool, but it really needs to be used responsibly.
Right, of course.
Typically, network administrators, they define rules and priorities based on, what the organization needs and what the users need.
Right, the needs of the organization and its users.
Exactly. So, for example, a hospital might prioritize medical imaging data over email traffic to make sure that, critical patient information is transmitted quickly and reliably.
That's a great example.
Yeah.
Okay, so now how does QoS at the data link layer relate to the other things we've been talking about, like SDN, SPB? Do they all work together?
They complement each other beautifully.
Okay.
SDN provides that centralized control and flexibility to actually define and implement those QoS policies across the whole network.
Right.
SPB makes sure that the prioritized traffic is taking the most efficient route.
Got it.
To its destination.
So they're all working together.
They work together.
It's like a well-coordinated team.
Yes.
SDN is the strategist.
Yeah.
SPB is the navigator. QoS is the traffic manager. And they're all making sure that the network is running smoothly.
They keep things moving.
Now, I'm thinking about the Internet of Things, IoT.
Yes.
It seems like every day there's a new device.
I know, right?
Connecting to the Internet, from refrigerators to health monitors that you wear.
It's amazing.
How do all of these advancements that we're talking about in data link control, how do they impact IoT?
So the IoT presents both challenges and opportunities at the data link layer.
Okay.
On the one hand, you have this huge influx of devices all generating their own data streams.
Right. That's a lot of data.
And it can put a strain on network resources if it's not managed effectively.
Right. It's like if you have a sudden population boom in a city.
Yeah, exactly.
The existing infrastructure might not be able to handle all the extra traffic.
You got it.
So this is where SDN and SPB become even more important.
Exactly. SDN lets you create these virtual networks that are specifically for IoT applications.
Oh, yeah.
So you're isolating their traffic from the rest of the network.
Got it.
And SPB ensures that the data from these devices is taking the most efficient path, right? So you're minimizing latency, maximizing that network performance.
So it's like creating separate neighborhoods for different types of IoT devices.
Exactly.
With their own, like, dedicated transportation system.
Got it.
And then QoS is making sure that, like,
Yes.
the important data is getting through.
Absolutely. So that critical IoT data, things like sensor readings, alerts, gets prioritized even when the network is busy with other traffic.
That's like having a dedicated lane for ambulances
Yeah,
to make sure they can always get through.
even in rush hour.
Now, I'm thinking about security.
Yes.
With so many devices connecting to the network,
Right.
it seems like the attack surface would be enormous.
It is.
How do we secure IoT at the data link layer?
So security is absolutely paramount in the IoT.
Okay.
And especially at the data link layer, because remember, a lot of these IoT devices, they're designed with very limited processing power and memory. So it's really hard to implement those complex security measures directly on the device itself.
So we can't rely solely on the device to protect its own data.
You got it. We need to look at other layers of defense. And that's where things like 802.1x and MACsec come into play.
Right, because we were just talking about those.
Exactly. So by authenticating devices and encrypting that data at the data link layer, we can create a really strong security perimeter, even if the devices themselves are vulnerable.
Right.
It's like having a security checkpoint at the entrance to a city, right?
Yeah.
You're screening everyone who enters rather than relying on each individual to protect themselves.
That's a great analogy.
Yeah.
And as IoT continues to grow, I imagine we're going to see even more innovative security solutions.
Absolutely. We're going to see new solutions emerging at the data link layer, specifically designed to address the challenges of this, interconnected world.
And it's just amazing to see how all these advancements are shaping the future of networking.
It is.
It's a whole new world out there.
It really is.
What else is there? What other exciting developments should we be aware of?
So one area that's getting a lot of attention is the use of artificial intelligence.
Okay.
Or AI
Right.
for network management.
AI for networks.
Yeah, so AI algorithms.
Okay.
They can analyze huge amounts of network data.
Wow.
They can identify patterns
Okay.
and actually predict potential issues before they even happen.
So it's like having a digital doctor
That's a great way to put it.
for your network that's constantly monitoring the vital signs.
Exactly. It's like preventative medicine for your network.
And if something's wrong, it can prescribe the right treatment.
Yes, AI can help optimize performance, enhance security, and even automate those routine tasks.
Right.
So human administrators can focus on, more strategic initiatives.
So it's like the network is becoming less like a static infrastructure
Right.
and more like an intelligent assistant.
Exactly.
It's constantly learning and adapting to our needs.
That's the goal.
That's pretty amazing.
It is.
But doesn't this also raise some concerns about, control and accountability?
It does.
Like if an AI makes a mistake,
Right.
who's responsible?
Yeah, those are really important questions that
Sure.
we need to think about as AI becomes more integrated into network management.
Okay.
Transparency, explainability, and human oversight
Yeah.
are all going to be critical
To make sure that AI is being used responsibly.
responsibly and ethically.
Ethically, yes.
Yep.
It's like any powerful tool.
Right.
It can be used for good or for bad.
Absolutely.
And so we need to make sure that we're using it to enhance our lives,
Right.
not create new problems.
Exactly.
And this actually leads to another important thing,
Okay.
which is the human element.
Yes. Human element.
It's easy to get caught up in all the technology
Right.
and forget that there are people
Real people.
behind all of this,
Absolutely.
designing it, building it, managing it.
Yes.
How are all these changes impacting network administrator?
Yeah. So the role of the network administrator is definitely evolving very quickly.
Okay.
In the past, it was all about configuring devices and troubleshooting problems.
Right, like the hands-on stuff.
Right. But today it's more about orchestrating complex systems, defining those policies, ensuring security across this vast interconnected landscape.
So it's less about the hands-on tinkering
Yes.
More about strategic planning and automation.
Exactly.
It sounds like it's becoming a much more demanding role.
It is.
But also, I imagine, more rewarding.
It can be, yeah.
They're like the architects of the digital age.
It's a good way to put it.
Shaping the infrastructure that underpins our connected lives.
Absolutely.
So before we wrap up this segment,
Okay.
I want to come back to something you mentioned earlier.
Sure.
About the ethical considerations around AI
Yes.
and network management.
Right.
Can you elaborate a little bit more on that?
Sure. So as AI gets more sophisticated and autonomous, we really have to be mindful of those potential biases that can creep into the algorithms and the data that they're trained on.
Right.
Because these biases, they can lead to some unfair or discriminatory outcomes.
Especially when it's being used for something as important as, network security.
Exactly. Or resource allocation.
Right.
So it's not just about the technology itself.
Right.
It's about the values and principles that are embedded in the design and how it's implemented.
So we need to make sure that AI is used in a way that aligns with our ethical principles.
Absolutely. Promoting fairness, transparency, and accountability.
And how do we do that?
Well, organizations need to establish clear ethical guidelines for AI development and deployment,
Okay.
conduct those risk assessments, and implement robust monitoring and auditing mechanisms.
It's like creating a set of rules and regulations for the digital world
Exactly.
to make sure that AI is serving humanity,
Yes.
not the other way around.
That's the goal.
And as the lines between, the physical and the digital world continue to blur, these ethical considerations are just going to become more and more important.
Absolutely. It's going to shape how we live, how we work, how we interact with each other.
It's a fascinating and thought-provoking conversation.
It is.
And I'm really eager to dive deeper into these ethical implications.
Yeah.
But for now, let's take a short break.
Okay.
And then we'll come back
Sounds good.
with a fresh perspective on this rapidly evolving landscape.
All right.
Okay, so let's continue our deep dive into data link control.
All right.
We've covered a lot of ground, from those security protocols to IoT and AI and network management.
Yeah, we've been all over the place.
What really stands out to me is just how interconnected everything is.
It really is.
It's like a giant web,
It is like a complex ecosystem.
Yeah, each advancement is kind of influencing all the others.
Constantly evolving and adapting. And, as we move towards an even more connected future, that data link layer, it's going to play an even more critical role.
Right. And speaking of a more connected future, I'm thinking about 5G.
Yes.
5G.
It's been, talked about as a game changer for mobile connectivity.
It is a game changer.
But I haven't really heard that much about its impact on data link control.
Right.
How does 5G fit into this picture?
So 5G brings a whole new level of complexity and opportunity at the data link layer.
Right.
The increased speed and lower latency. It enables all sorts of new applications and services.
Right. So we're talking about augmented reality. We're talking about autonomous vehicles.
All of that and more.
Wow.
But it also means that we have to really rethink how we're managing and securing data at this very foundational level.
So it's not just about upgrading our devices and infrastructure.
Right.
We need to be thinking about those underlying protocols and security mechanisms as well.
Exactly. Because 5G networks, they're designed to be much more flexible and dynamic than previous generations.
Right.
They use something called network slicing.
Network slicing, okay.
Which basically allows operators to create multiple virtual networks
on top of the same physical infrastructure.
So it's like having a highway with dedicated lanes
Yes.
for different types of vehicles.
Exactly.
And each one's traveling at a different speed.
Right.
With its own set of rules.
That's a great analogy.
It's a pretty amazing level of flexibility.
It is.
But how does all this impact data link control?
Well, those data link control protocols, they need to be able to handle this increased complexity.
Okay.
They have to seamlessly transition data between those different network slices.
Right.
Make sure that QoS policies are being enforced and maintain security in this dynamic environment.
And so that sounds like a pretty significant challenge.
It is.
Are the existing protocols like 802.1x and MACsec, are they up to the task?
That's a good question.
Or do we need to come up with brand new protocols specifically for 5G?
So that's a question that, researchers and industry experts are really actively exploring.
Okay.
Existing protocols, they provide a good foundation,
Right.
but they might need to be adapted or enhanced to fully meet the demands of 5G.
Gotcha.
We're also seeing new protocols and security frameworks that are being developed specifically for 5G,
Okay.
leveraging things like software-defined security and blockchain for, better security and trust.
So it's like we're building a whole new set of tools and blueprints for this 5G era.
We are.
It's exciting, but also kind of scary.
It is. There's a lot to think about.
Yeah, it's like, what are the potential pitfalls that we need to be aware of?
And that's why it's so important to have these open and collaborative discussions
Right.
about the future of data link control.
Mm-hmm.
We need to bring everyone together, network engineers, security professionals, the software developers, policymakers. Everybody share knowledge, identify those challenges,
Right.
and develop solutions that ensure a secure, efficient, and equitable digital future.
For everyone.
For everyone.
And so collaboration and a holistic approach,
Yeah.
these are kind of like recurring themes in our conversation today.
They are.
And it makes perfect sense.
It does.
You can't solve these big, complex problems in isolation.
You can't.
You really need to bring people together
Absolutely.
with different perspectives, different expertise,
Right.
and come up with solutions that benefit everyone.
That's how we move forward.
So any final thoughts for our listeners?
Well, the data link layer, it might seem like, just a technical detail
Right.
hidden beneath the surface.
It's kind of invisible to most people.
It is, but as we've seen, it plays such a crucial role in shaping our world, our connected world.
Absolutely.
The advancements that we've talked about today, it's not just about speed and performance.
Right.
It's about creating that more secure, resilient, and equitable digital future.
For everyone.
For everyone, so stay curious, keep learning, and be an active participant
Right.
in shaping this exciting new era.
Those are great words to end on.
Thank you.
It's been a fascinating journey.
It has.
Exploring the world of data link control.
Absolutely.
And I feel like I've learned a lot.
I'm glad to hear that.
I have a whole new appreciation for the, those invisible forces that keep our digital world running smoothly.
Yeah, it's amazing when you think about it.
And I'm excited to see what the future holds
Me too.
for this really dynamic and constantly evolving field.
Yeah, there's so much more to come.
Thank you for joining us on this deep dive.
Thank you for having me.